Hi all, welcome back to Computer Organization course. We'll get started. Next we will study about condition codes. Now whenever processor does some task, it keeps track of the information about the results of various operations for use by subsequent conditional branch instructions. Now how is this accomplished? This is done by recording the information in individual bits often called as condition code flags. Now, these flags are grouped together in a special processor register, and that is called as status register or condition code register. Now, the value of this status register or condition code register will be set to 1 or cleared to 0. The four commonly used flags are negative flag represented by N, 0 represented by Z, overflow V, carry C. Now, this negative and 0 flags indicate whether the results of the arithmetic or logic operation is negative or 0. So, whenever the result is negative, the N flag is set to 1, otherwise, it is cleared to 0. So, and whenever the result is 0 for any of the operation, the Z flag is set to 1 or it is 0. Now, these flags will be affected by instructions that transfer the data such as load, store or move. Okay. The next is V flag. This indicates whether the overflow has taken place. So, whenever overflow occurs, V flag is set to 1 else cleared to 0. The C flag is set to 1 if a carry occurs from the most significant bit position during a arithmetic operation. So, whenever a arithmetic operation is taking place and there is a carry, this flag C is set to 1. Otherwise, it is set to 0. Next, we will study how to generate memory addresses. For this, we will consider this diagram. We have already seen this, right? Adding of n numbers using loop. Okay. Now, what is the purpose of that loop block there? It will add different number from the list during each pass through the loop. So first num1 is added to the register R0, next num2, then num3 likewise. Okay. So the add instruction in that block must refer to different addresses during each iteration or during each pass. Now how these addresses are specified? There should be some way, right? So we can use a processor register from R0 through Rn-1, any one of these, to hold the memory address of the operand. Now, first what happens? The address of the num1 is loaded. Before the loop is entered, the num1 address is loaded into this register. Then it is incremented on each iteration through the loop, so that for the first iteration num1 value will be taken, for the next iteration num2 value is taken, and so on. Now, the instruction set of the computer, it provides a number of such methods called as addressing mode. Now, how do you specify the address in the operand? It will be given in a addressing mode. Next, we will see the same addressing mode. Okay. The data is organized in variety of ways inside the memory. So if you want to keep track of, suppose, say, student name, what we can do? We can write it in a list. Now, as the developers or the programmers, what they do? They use something called as data structures. So these data structures include stack, linked list, arrays, queues, etc. Now, whenever the programs are written in a high-level language, it enables the programmers to use constants, local and global variables, pointers, and arrays. Now, these things can store the data. So, whenever a high-level language is converted into an assembly language, the compiler must be able to implement these constructs using the facilities provided in the instruction set of the computer. Now, the ways in which the location of the operand is specified, we call it as addressing modes. There are many addressing modes as you can see in the table. That is immediate addressing mode, register, index, likewise. First we will see the register mode and the absolute addressing mode. So what happens here is in the register mode, so the operands of the are the contents of a processor register. Okay. Now this one, R2 is a processor register. So whenever this R2, R1, R2 or any special purpose register is found in the instruction, we say that is a registered mode. Suppose for example, so say suppose we have this instruction move R1 comma R2. So this is an example for register mode. So here the operands are the contents of a processor register, that is R1 and R2 are the operands here. That's why we call it as a register mode. Okay, the operands, both the operands are the contents of a processor register. Next is absolute mode. Now here what happens, the operand is a memory location like this. Sometimes this absolute mode is also called as direct mode. Okay, now in the absolute mode what happens, only the operand is in a memory location, not in the processor register. Okay, now this example move loc comma r2, it's a combination of both. It is a register mode as because R2 is present. It is also a absolute mode because the memory location LOC is present. So this is an example for both the modes, register and assembly. Okay. Now the absolute mode, how can we refer to it as integer a comma b. Now this is an example of absolute mode. Here a is a memory location, b is also a memory location. Integer, it specifies that your program, suppose if you have integer a comma b, it says the compiler to allocate the memory location for the variable a and b of type integer. Getting it? Next we will see the immediate mode. So here what happens is, suppose the operand you have to give uh, a value directly. Okay, so say suppose you want to load some say suppose 100, this value 100 into some register, or value 200 into some register. So in this case we will use immediate mode. So here it says that the operand is given explicitly in the instruction. Here this value is directly given in the instruction. Instead of any memory location or register, you give the value directly in the instruction. So this is called as immediate mode. So how can we write that? So we write in this one, this way, move 200 immediate comma r naught. Now what it does, the value 200 will be placed in register r naught. Getting it? Now so using of this subscript is not appropriate in assembly languages. We can understand this by just reading it is an immediate mode, but you cannot use this in assembly languages. So instead of this, what we can do is we can use a sharp sign or pound or hash. Okay, so we can write something like this, move hash 200 comma r naught. Now what does this instruction say? It will move the value 200 into the register r naught. Okay. Next we will see how the constants are represented. For example, take this instruction a is equal to b plus 6. This says the value 6 should be added to the contents of the memory location b, and it has to be stored in a. Okay, now how can we write this? So we can write it in this way, move b comma r1, so the contents of b will be placed in r1. Now add hash 6 comma r1, that means add 6 to the content of r1, that means nothing but the content of b. Now move the value or the sum to a. So this is nothing but a snippet for a is equal to b plus 6. Next we will have a small quiz, and the question here is move hash comma 200 comma r naught. Which type of addressing mode does this instruction specify? You have 2 minutes of time. Okay, time's up. Next we will study about indirect addressing mode. Okay, so here in this mode what happens is the instruction, whenever you have an instruction, the operand address is not given directly. Instead of that, it provides the information from which memory address the operand can be determined. Now we refer to this address as effective address. Remember, it is effective address of the operand. So in the indirection mode, what happens? The effective address of the operand will be the content of a register or memory location, and that registers or memory location's address would appear in the instruction. For example, if we have this instruction add R1, R0, remember we have a parenthesis over here. So this represents the indirect addressing mode. This parenthesis represents indirect addressing mode. Here, what happens is you have R1 in the bracket, right? Inside the bracket. So what it says, whenever this instruction is getting executed, the processor will understand this is a indirect addressing mode. The processor, what does it do? It first goes to the this register. Okay, it goes to register R1. Now what are the content of register R1? This register R1 contains a memory location B. Now the processor, what does it do? It sends a read signal to the memory. Again, whenever a read signal is sent to the memory, it goes to this particular location B, and then the operand, actual operand or the data is fetched. Once the data is fetched, again it is added to R0. Getting it? Now, we will take another example wherein the effective address of the operand is a memory location. Here, add A, R0. A is in parenthesis. This specifies it says the processor that this is a indirect addressing mode. Now what does the processor do? It will first go to the location A and it will see that there is one more memory location present, which is B. Again, a new read cycle is initiated. Now what happens here? Whenever a new read cycle is initiated, it goes to this particular location B and the data is fetched or the operand is fetched. Then it is added to the register content R0. Okay. Now the register or the memory location that contains the address of the operand, we call it as a pointer. In our case, here this R1 and A, we call them as pointers. Okay, because they have the address of the operand. Now we will consider the same example wherein we add the n numbers, adding of the n numbers, and how can we use indirect addressing mode to that, and how can we write a program for that using indirect addressing mode. Let's see. So this is how we can write a program here. Okay, so what happens here is first we will move the contents of n to register R1. Say suppose n we have, say suppose it is 5, n is equal to 5. That means we want to add 5 numbers. Okay, we want to add 5 numbers and we want to find the sum of that. Now what happens? First the contents of n will be moved to R1. Next we will move hash num1 comma R2. Now what happens here is the program loads the counter value. First we understood this one, right? N to R1. Now hash, this represents the immediate addressing mode. Now using this immediate addressing mode, what we can do is we can place the address value of num1 into register R2. In our case, R2 would act as a pointer. Okay, R2 would act as a pointer. So then we will clear the register R0. Now this is the initialization. First what we will do, R1 will act as a counter which will tell us how many numbers to add. Next, the address of the first number. Okay, we have num1, num2, num3 till 5, right? So that address one by one it would be loaded into R2 and R2 would be considered as a pointer. Next we will clear R0 to add the numbers. So this is our program initialization. Next what we will do, we will add R2 comma R0. Now we have here parenthesis, right? Your processor will understand this is the indirect addressing mode. Whenever there is a parenthesis, it understand it a indirect addressing mode. Now what happens here is R2 contents would be added with R0. Now what is the content of R2? It is num1. Now we have hash num1 here. This means R2 contains num1 and actually you have to go to num1 and take out the operand and you have to add it to R0. That's why I said R2 is a pointer in our case. Okay. Next we have add hash 4 comma R2. Now hash 4 here your processor understands that it is a immediate addressing mode. Now whenever you add 4 to the content of R2, what it does, it will point to num2. Whenever num2 is added, then again whenever this add hash 4 comma R2 is executed, it will point to num3 and so on. Okay. So this decrement R1 branch greater than 0 loop, move R0 comma sum, we know how this will work, how this iterations work and how the 5 numbers will get added. Okay. Hope you understood this indirection and pointers. Now these are the practice questions for today. Write a note on conditional codes, describe register and absolute addressing mode, and third is illustrate with examples indirect addressing. Okay. You know how to write and how to send these things, right? I'll tell you the date, final date when to submit this one. That's it for today. We'll conclude our session. Thank you.